Hi everybody, in this video we're going to be looking at the topic of how do I write quantum numbers. I've selected 3 electrons for us to look at. We're going to be looking at electron number 1, number 6, and number 29. Now let's think about what it means to write quantum numbers and what the different quantum numbers are. There's an acronym that I would encourage you to remember to work with this. It's PAMS. P is for principal. This is the first quantum number. It tells me the energy level that an electron is located in. A is for angular. This is the sublevel, which is the location of an electron. M is for magnetic. This is telling me which orbital is an electron placed into. Finally, S is for spin. This is telling me if I have an upspin or a downspin electron. Now, as we consider the process of determining quantum numbers, I want to go ahead and draw a table here, and I'm just going to skip forward a little bit so we can fill this in. We have S for spin, M is for magnetic, and we have A for angular, and we have P for principal. So these are, again, the 4 quantum numbers that can describe the position of any electron. Let's consider first electron number 1. This would correspond to the element hydrogen, because hydrogen has the atomic number 1. If I was writing an orbital notation for hydrogen, I would have an up arrow in the 1s orbital box. Now, let's determine the 4 quantum numbers for electron number 1. The energy level is given to me by the coefficient in the electron configuration. So this electron is in the first energy level, so my p-value will be 1. The principal quantum number is 1. The angular number is telling me the sublevel. It is in a 1s sublevel. The angular value will always be 0 for s sublevels. Your magnetic value will always be 0 if your angular value is 0. Finally, the plus 1/2 tells me I have an upspin electron in the 1s sublevel, the 1s orbital. Next, let's consider electron number 6. This corresponds to the element carbon. Now, I'm just going to write the very final part of the orbital notation, 2p2. I need 3 orbital boxes, and I need to remember the order for filling. Start all the way over at the left, and then I move to the middle box for that final electron to give me 2p2. The principal number will be 2 because this electron is in the second energy level. The coefficient is telling me that. Now, an angular value of p, angular value of 1 tells me I have a p sublevel. Next up, I need the magnetic value. Now, the magnetic value is a little bit tricky, and that's going to be 0 for this element. For this electron, the spin value is plus 1/2 because it's an up arrow. Now, let's get back to this magnetic. Where did this come from? For the magnetic values, it's actually not too hard to remember this. You're just going to number the orbital boxes if you have more than 1 for a sublevel. So in a p sublevel, we have 3 orbital boxes. The central one will be numbered 0. That's why this was a value of 0. This is the -1 box. This would be the +1 box. And let's take a look at one more example, which will give us an expanded sublevel so we see more numbers. All right, continuing, let's take a look at electron number 29. This corresponds to the element copper. Now, copper on the periodic table has a total of 29 electrons. So that's copper. Now, this is in the 3d sublevel, and the final part of the orbital notation would be 3d9. So I need to draw my 5 orbital boxes, and I need to start filling them with electrons in the appropriate order. So all the orbital boxes get up arrows first, followed by down arrows, always moving left to right. So my 9th electron is being placed in this orbital box right here. My principal quantum number is 3, which comes from the coefficient 3 right here. My angular tells me the sublevel, D, is a number 2. And then I need to number my boxes. 0, -1, +1, -2, +2. So this down arrow is in the +1 orbital box. It's a down electron, so -1/2. Additional notes, if you have an electron in an F sublevel, your angular value will be 3. Let's take a look at the magnetic values, orbital. This S would have just a 0 In a p sublevel, remember we started 0. I've got -1 on the left, +1 on the right. If I'm in a d sublevel, 5 boxes, -2, -1, 0, +1, +2. Finally, if I'm in the f sublevel, this means that there are actually going to be 7 different orbital boxes. And I start numbering those at the far left with -3, -2, -1, 0, +1, +2, and +3. So this has been a look at how to determine quantum numbers for electrons. The final note is, don't forget the spin. Up arrows are +1/2, down arrows are -1/2. Thanks for watching, and good luck with all of your chemistry homework.